Hello guys, so we are going to continue the discussion with respect to multi-threading and multiprocessing. In this video, I'm going to take a real world example for multiprocessing, and here for the different kind of task that we are focusing on is nothing but CPU bound task. Now here, the factorial calculation that we are going to do, we will be doing for larger numbers, okay? It involves significant computational work. So with the help of multiprocessing, what we'll do is that we'll distribute the workload across multiple CPU cores, improving the performance. Okay, so this is what we are planning to do it in this particular video. I will take up a list of bigger numbers and we'll try to calculate the factorial. Now you know that for calculating each and every factorial number for a larger number specifically, it is going to take time. What we will do is that we'll take multiple numbers and we'll divide that into multiple processes and we'll implement it. Otherwise, CPU will continuously take, one core will be taking up, there will be some empty cores. Instead of waiting for that particular core, what we can do is that we can create a new process and we can assign the other CPU core itself. So that is what we are going to discuss. So let's quickly go ahead and start implementing it. Okay. So first of all, we are going to import, I'm going to import something called as multiprocess. Okay. Multiprocessing, and then we are also going to import math. We are going to import sys. Along with this, we are also going to import time, so that we'll also measure time in this example. Okay. Now, with respect to any kind of operations that we do, right, mathematical operation, we need to set our digits, right? What will be the max int max str digits, right? Like how much maximum digits we can work with. So here I've actually given at 1 lakh, okay, 100k. So increasing the maximum number of digits for integer conversion, right? We'll be keeping this, otherwise we'll not be able to do the particular operation, right? Because we are going to calculate the factorial for a bigger number. Now here I will go ahead and create our function, and remember this we basically set it in our system library, okay? So function to compute factorial of a given number. If we don't set this up, you'll be getting an error once we probably execute this entire program. Okay, it looks like a hack, like someone is trying to hack in the system by doing such a bigger operation, right? So it will restrict, the system is basically getting restricted. So here I'm going to probably go ahead and compute my factorial, and here I am going to take my number. Okay, now with respect to this particular number, here you'll be able to see that I'm printing. Let's go ahead and print my f string. We will go ahead and compute the factorial of a specific number. So factorial of a number, the number is provided in the parameter. Okay, and then we will go ahead and write result is equal to math dot. So math has that function dot factorial, and we'll use this inbuilt function by giving this number inside that. Okay, once we get the result, then what we will do, we will quickly print this particular factorial over here and return the result. So this is the function that we are going to call, and we'll call it with the help of multiple process. The reason is very much simple. Let me go ahead and create my entry point. So if underscore underscore name underscore underscore double equal to underscore underscore main underscore underscore. Okay. So here we are going to basically use this, and let me just go ahead and create my numbers. The numbers will be 50,000, 60,000. Let's say, or I'll just take a little bit smaller, otherwise it will be very, very big, right? It'll 6,000, 7,000, 8,000. Okay, so this many number of factorials I really want to calculate it. I will say, hey, let's start the timer over here. So I'll say start underscore time is equal to nothing but time dot time, right? So once I use this time will probably start. Now we will go ahead and create a pool of worker processes. Okay, now here I will go ahead and write with multiprocessing dot pool. I'm going to basically use as pool, so this will be my context. Okay, and with the help of this particular pool, we will be able to map our function with this all numbers. So here I'm just going to go ahead and create my results. Okay, results, and here I'll write pool dot map. Okay, we are just going to map this based on the context. Let's call our function compute factorial, and here we are going to give our numbers. Okay, and finally we end our time over here by writing time dot time. Okay, Finally, let's go ahead and calculate the results or print the results, and along with this print we will also go ahead and calculate our time. So time taken will be end time minus start time seconds. Okay, now over here you can see what we are doing. We are probably calling this particular function with multiple multiple processes. Along with this, what we are also doing is that we are giving this entire list of numbers, right? And this is a huge number to calculate the factorial. Now let's see this and let's try to run it and let's see whether it will be able to do it fast or not. And now in short, we are just going to use all the cores, and I really have a wonderful CPU. I have, I think, 32 cores in my CPU, right? So obviously I'll be able to get a quickly result, right? So let me just go ahead and write Python. And here I'm going to just say factorial underscore multiprocessing.py. So once I execute it, so here you can see how fast, hardly took 0.4375. Okay. If you just go ahead and execute this just with the help of map, right? If you just use for loop and try to compute this, it is going to take time. Don't try it out because your system will get hanged just by using one CPU core. But here you can see I'm using all the CPU core, and this is the values that I'm actually getting over here, right? And it's huge. And over here you can see the time taken is this many number of seconds. So I hope you were able to understand from this amazing example of factorial with respect to multiprocessing. This was it about the module of multi-threading and multiprocessing. I hope you like it. I will see you all in the next video. Thank you.